Good day guys, I hope you're good. So today we are going to be looking at this question here that is based on Euclidean geometry. However, now what we're going to be looking at, it's the ratio of areas, right, of different triangles, right? And what is it that we have to look for, right? So we are having the first case here, right? So remember that guys, there are actually two ways in which you can calculate the area of a triangle, right? So one, we know that we can use the normal area formula. The other way in which you can calculate the area of a triangle is to use the sine rule, right? So now here's what we are going to do. If now the area of what, of a triangle, right? If now two triangles are sharing the same vertex, if two triangles are sharing the vertex, the ratio of their areas is going to be equals to the ratio of their bases, right? So if we know that we have two triangles that are sharing a vertex, their ratio of their areas, they are going to be actually equals to what? They are going to be equals to the ratio of their bases. Then now that's what we know. Then the other thing that we have to know is that if we are having two triangles, all right, if you are having two triangles, then those two triangles are actually having what? Are actually sharing what? They are actually sharing a common angle, or they have a common angle. Those two triangles, if we are looking to calculate the ratio, we are going to do what? We are going to use the sine rule, right? We use the sine rule. So now let's have a look at the first part of the video here. So you're having that you have to calculate the ratio of triangle ABQ over the area of triangle, what, of triangle ACQ, right? So that's what we have to calculate. So now let's look at ABQ over triangle ACQ. I have already tried to highlight here. So ABQ, it is this part of the triangle, ACQ is this part of the triangle. So now if we look at those two triangles there, those two triangles are sharing a vertex. Which vertex are they sharing? They are sharing the vertex A, right? So what did we just say? That when two triangles are sharing a vertex, what's going to happen? They are actually going to also share the height, right? So it means that their heights are going to be equal. In other words, that it's that the area of triangle, what, of triangle ABQ, right, is going to be calculated in the following way: half times the base, right? But then we said that when two triangles are sharing what, are sharing the same vertex, they are going to share the same height. How so? This is what we are going to construct the perpendicular height from vertex A. So this is what we are going to have, right? This perpendicular height here, it is a height for, or an altitude for, triangle ABQ. At the same time, it is also a height for triangle AQC. Why is that? Remember that when we are constructing a height for an obtuse triangle, we always construct it externally, right? We construct it externally. So according to ABQ, what is the base? The base is BQ, right? And then according to the height, since now we know that the base is BQ, right? Our base is BQ, our height is going to be H. Then we have all over this, we're going to have over here the area of triangle, what, ACQ. Then we're going to have half times QC times the height here. Then what are we going to be left with here? The 1 over 2 cancel out with the 1 over 2. We're left with 1 there. The H, because they are equal, right? They are the same. Then what are you going to be left with? We are going to be left with BQ over QC. Then now, according to this, what is BQ over QC? BQ over QC. BQ is a base of the first triangle. CQ is the base of the second triangle. Hence why we stated before that if two triangles are sharing the same vertex, they are going to, the ratio between their areas, it is actually going to be equals to the ratio between their bases. Right, so this is base number 1. BQ is base number 1, which has a value of 4x, and then QC is base number 2, which has a value of 3x. Then this is going to be simplified into 4 over 3. So this is how we answer the first question. So you can see that the two triangles there, they are sharing the same vertex. Therefore, we are going to use what? We are going to use that the fact that when two triangles are sharing the same vertex, they are going to have the same height. And then if two triangles have the same height, their ratio, the ratio between their areas, is going to be the same as the ratio between their bases. So that's how we answer our first question. So our next video here, we are going to be looking at the second part of the question, right? We're going to be looking at the second part of the question.